Accelerometers aren't immune to this either. You know, the cable, again, has resistance or capacitance it builds up that causes higher frequencies to be attenuated, or maybe not even carried at all. So they'll be reduced or eliminated, you know, and up to a certain frequency, everything's passing. To determine if you have that as an issue or not, there are things like this nomograph that can tell you what the highest frequency is that you can measure given a certain setup. It has the capacitance of the wire on one, and it has the voltage being measured on this axis and takes into account the current supply. So if I look here, 100 feet, 300 picocoulombs per foot, that's 3,000 picofarads. I said picocoulombs, didn't I, Scott?
You sure did.
Picofarads.
I didn't have an
Too
opportunity.
many times.
Just once.
Okay. So this that puts us on this line. You can see the versus frequency here. It's attenuating, right, over as it goes higher in frequency. So it's attenuating as it goes higher in frequency. And here's all this voltage stuff. So if we have a 5-volt signal we want to measure, 2 amp supply, we're at 5 here, and this line intersects this line right here, and if we look down, that's 10 kilohertz. What it's saying is we can safely measure right around 10 kilohertz with this setup. What if I want to measure more high in frequency?
Higher in frequency. You either need a lower capacitance per foot of cable, so maybe a more expensive cable, or you could lower the y-axis, which would be changing either the current or the voltage supply there.
Yeah, it's not a supply for the voltage. That's actually what we're measuring, but that's the current supplied to the transducer.
Yes.
Yeah, we could say, well, I don't need 5 volts coming back through the wire. I only need to measure up to 1 volt because I use a less sensitive transducer. But is that a good idea?
Probably not, depending on the signal, but yeah, typically you don't want to. Less sensitive transducer is going to be more susceptible to noise.
Yeah, exactly. So if we give up on this 5 volts, we're susceptible to noise. This is more expensive, right?
Yeah.
Typically low resistance cable. You can also play with the current. So here, we'll increase the current to 9 milliamps. We recalculate this line, and now we're up to 100 kilohertz. So if you can, for the same setup, increase the current supply for the transducer, that also helps go up higher in frequency.